You are building a system that utilizes a multi-partitioned Azure Cosmos DB database and are utilizing the latest version of the Azure Cosmos DB SDK. The application must satisfy these requirements. 1. Forward all insert and update data to an Azure Blob storage container. 2. Handle all partition updates in real time. 3. Enable parallel execution of the change processing logic. Select two methods that appropriately address these requirements.
Option A. Deploy an Azure App Service API that utilizes the SDK's change feed estimator and scale the API by increasing the count of app service instances. Implement a persistent background process in Azure Kubernetes service that utilizes the SDK's change feed processor capability. Option C. Implement an Azure function with an Azure Cosmos DB trigger that is linked to the source container.
Option D. Implement an Azure function utilizing a feed iterator to pull changes from the container, incorporating a feed range to manually split the processing tasks across several function instances. This question focuses on processing change data streams from a distributed NoSQL database in real time. Specifically, we need to consider how modern SDK features handle high-throughput partitioning, parallel execution, and automated scaling to forward data downstream without building complex manual polling loops. In my view, the correct answers are options B and C.
Option C is correct because the Azure Functions trigger for Cosmos DB is the standard serverless implementation that handles automatic scaling and parallelization across all partitions seamlessly.
Option B is also correct because using the change feed processor library within a containerized environment like Azure Kubernetes service allows developers to manage partition processing and achieve parallelization by distributing load across multiple service instances. Option A is incorrect because the change feed estimator is simply a monitoring tool used to track progress and lag, rather than a mechanism to perform actual data processing. Option D is less optimal because while the pull model is available in the modern SDK, manual implementation of cross-function parallelization using feed range is significantly more complex and resource-intensive to maintain compared to the built-in trigger or processor library.